Hello everyone, I'm Professor RVD and welcome to placement interview questions on data structure. So the next question is, what is an abstract data type? Okay, before doing anything further on data structure, one needs to know about abstract data type, or we generally call it as ADT. So let's try to understand what is an abstract data type, okay, and then we'll see maybe some examples of abstract data type also. See, generally, when any new abstraction or any new design you want to build, you require to communicate that to other. And the way you communicate your design or your system is through abstract data type. So whenever I want someone to know what is my system, I obviously want two things to be very clear. That is how the elements can be stored in my system and how the various operations can be performed on my elements in my system, because the operations would be very specific to your system. So these two things together, when you try to formulate, it is nothing but the abstract data type. Okay, so ADT is a mathematical model which is defined by a set of values and a set of operations. So that's what I said, storage and operations. Okay, so why it is called as abstract data type as such? See, it is called as abstract because it provides implementation independent view of the system. See, understand one thing, any data structure when you design at the initial stage, you might not be clear yourself that in which language you will be implementing this particular data structure. So whenever we are designing a data structure, we always expect that the data structure must be, the design of the data structure must be independent of any programming language. So that whenever we'll try to convert this or implement this into a programming language, we will obviously have a less trouble. And your ADT will exactly try to give you the same. Language independent design of the system is ADT, and that's the reason it is called as abstract. It is also refers to the process of abstraction, where only the necessary details are shown and the other details are hidden. Okay, so you know the kind of an object-oriented concepts of abstraction, where only the required part is shown to the user and the internal complexities are kept hidden. So similarly, through abstract data type, we are just making the user aware that what are the different operations that can be performed on my data structure. Okay, whereas the internal complexities of the operations are being stored in the form of the algorithm. Okay, so let us look at some of the examples of the ADT. The very first one is a array. See, when array is combined with something like, if at all I have an array with some sort of tracking variable, and I'm defining the operations that how do I insert the element in the array, how can I delete the element, is there a provision of counting how many elements are there, or is there an operation of reversing the array. So that way I can try to use the existing array to create a new ADT as such. Okay, and that is how we can define. Again, see, when I said that I'll be defining ADT, I said I'll be storing it in an array and what are the different operations that can be provided. Maybe multiple people can have multiple ADTs created for the same concept of array. Okay. One more example is a set example. In a mathematics, you might have studied collection of elements as a set. The major difference between array and set is within a set, we cannot have duplicate elements. So if you visualize the insert operation that you have to define for set, you will not be able to insert directly because the element you want to insert, you rather prefer first checking that whether the element is already present by a search operation. If search returns true that the element is there, the insert operation should fail. And if the search returns false that the element is not already present, then only the insertion can be done. So see, when the same insert is on array and the same insert is on set, has got a different behavior. So when we design a set ADT, we have to clearly specify how the insert operation will work on set. Again, on set, we can have operations like union, intersection, difference, finding the cardinality of the set, and so on. Maybe one more example that we can have is a ratio. Again, we have seen in mathematics that ratio can be defined as numerator upon denominator, P by Q form. So we can have a ratio being stored as a combination of two integers, one is numerator, one is denominator, and we can define the set of operations like I can have addition, subtraction, multiplication, division of my ratio. I can even have reciprocal. I can even have maybe let's say displaying the ratio in an appropriate form, because again we have a limitation of displaying your numerator and denominator in a specific form. So how you want it to be displayed can be defined in a display function. Okay, so all such operations can be given to ratio and it becomes an ADT. Likewise, what different data structures you already know, which are being invented, like stack, queues, linked list, and trees and graphs, and all those things have their own ADT, which rather gives you an implementation independent view or design so that you can learn them and then think about implementing them using the appropriate programming language. Fine, so I hope you understood the concepts of abstract data type and how exactly we can think about or view various systems in a ADT form. Okay, so that's it for current video. Thank you.